to Space Aeronautics Preliminary Design Review and Lead 1. All right, before we get started, here's a quick agenda. First, we're going to start with team introductions. We have a lot of new faces. Your supplements are mostly random this year. Then we're going to go over our competition, Design, Build, and Fly, as well as our previous entries. Next, we're going to go into details this year's competition, mission requirements, the specific challenge, scoring criteria, tech expansion, as well as sensitivity analysis. Next, we're going to go over our competition aircraft, one, its overview and layout, as well as our schedule and budget. After that, our subcommittees will explain their parts and give progress updates on their ends. We will be starting with aerodynamics, structures, avionics, and banners. So for team instructions. First, myself. My name is Amir. I'm the project manager of Space Aeronautics. I am senior mechanical engineering major.
I'm Gil Rivas. I'm also a senior mechanical engineering major. I am the systems engineer.
Hello, my name is Francesco Viteto. I am a sophomore in mechanical engineering, and I am the chief engineer.
In our aerodynamics team, we have Rahul. In structures, we have Shane and Nathaniel. In avionics, we have Nathan and Jake. Here's our team structure. There will be 400 and the play wage. We are one of the two competitive project teams of rocketry. This year we have 3 sub-teams. Those are aerodynamics, avionics, and structures. Our payload sub-team is called banner system this year, and it is the mechanical engineering capstone team, which we'll get to that in a bit. We have 14 members, 7 of which comes from structures, 3 from avionics, and 4 in aerodynamics. And this year, our faculty advisor is Dr. Vaxilanis. All right.
So next is the structures.
Hello, I'm Nathaniel.
I'm Shane.
I work both the structures lead.
So for an overview of our team, this year we will be creating 2 aircraft, a prototype and a final aircraft. As the structures team, we are responsible for designing, testing, and manufacturing structural components for the first aircraft, doing the same with the second using our lessons learned first. We will be responsible for helping aerodynamics and various other sub-teams with their fuselage, wings, empennage, payload integration, and landing gear.
So our goals for structure is to make 2 aircraft. The first aircraft is going to be our test aircraft, where we're going to put it through rigorous testing for us to better make our designs better and refine them for our final aircraft and vehicle.
For our fuselage body, we are using an integrated fuselage design, foregoing the carbon fiber tail boom that we've used in previous entries. However, we are still going with previous entries' use of laser cut wooden components, creating a jigsaw design of frame ribs and bulkhead. This will be made either with a laser cutter with either a basswood or also with 3mm sheet construction. All of this will be covered in a monocot style skin. We really chose the integrated tail boom due to the just much larger internal volume and the adaptability of what we can do with that internal volume, especially with this year's team missions.
So our fuselage is going to be a 2-deck layout fuselage, where the top deck will have the cargo and passengers, and the lower deck have the avionics and the banner deployment system. Having the 2 decks helps us better organize the internal components and allows us to have the heavier components like the pucks and the avionics bay to be in the front of the plane to help us with our CG.
For our wing structure, we're going to be using a very similar construction style to our fuselage. They're going to be laser cut wooden components. They're going to contain longerons and ribs. There are going to be in total 3 carbon fiber pieces constituting 2 systems. There's going to be 2 20mm square tube spars as our main wing spars, and 1 1/4 inch carbon fiber rod reinforcement piece, and that will be used to counteract torsion near the wing tips. These are all going to again be covered in a monocot style skin. And as the aerodynamics team mentioned earlier, going to be utilizing the SD7032 airfoil.
Our empennage is gonna be a conventional airplane, a conventional style. We're gonna have two elevators and one rudder. It's going to have the same construction as the wings. It's going to be made out of laser cut wood and wrapped in monocoat. And the airfoil is going to be the NPC, the NACA 0012, based off of the aerodynamics team's announcement.
For control services this year, we have yet to consider, or not yet, we have yet to finalize a main decision. We have three main options that we have considered so far: styrofoam, 3D printing, wood. Are the teams trending this year towards using a 3D printing construction, especially on the ailerons, elevators, and rudders?
So there's two types of payloads, the ducts and the pucks. So through our calculation analysis, we went through different combinations, and we decided on 14 passengers and 4 pucks, 14 ducts and 4 pucks. This is due because of the space the passengers take up, and we cannot stack them. And with this, we are integrating this into our fuselage to make sure there's ease of accessibility, and so we can actually access them from the outside.
For our banner deployment system bay, we are working closely with the capstone team to create space on the aircraft for our banner deployment system. It'll be located on the lower deck and it will partially hang out the bottom. The integration is more than just an open space. There's also a requirement of finding mounting locations that work with the capstone team. And so that does mean that collaboration is required with banner systems and avionics, along with aerodynamics for the drag.
So for landing gear, we looked over 3 different landing gear configurations, and because of the banner system, where the banner cannot touch the ground during takeoff, because it's going to be located under the plane, we decided to go with a tricycle design, which has a single nose gear in front and 2 rear gears, wheels in the back. This gives us a larger ground clearance during takeoff, and our front landing gear, we're gonna construct it this year, and we're gonna also machine.
For our timeline this year, we are, of course, in the 3rd week of November. By the end of November, we should have finished up our CAD design for our first prototype. And then up until late December and early January, we will have been working on, designed, and created our prototype 1. After doing testing on prototype 1 with the assistance of various other teams, we'll then start the CAD design and finish our CAD design of our final prototype by mid-February up until CDR. Our manufacturing will then go past CDR, which is not shown in the timeline. Our design report will be taking place across the entirety of our assembly process in order to properly document our decisions and why we need them.
So our testing is very similar to the aerodynamics team testing, but we're more looking into the structure of wings. So on the wing load test, we'll fix one end of the wing to a fixed surface, and we'll put weights on the other end to see how much force our wing can withstand. And then we're also going to do CG tests to figure out where our CG is.
For our budget this year, we have a large excess of unused materials. This is due in part from purchase order meant for last year. So as you can see the image, we have quite literally a carload of materials used. This includes a large amount of carbon fiber spars and rods, and a large amount, about 50 sheets of each of basswood and balsa. Beyond the structure materials that we already have, our landing gear, filament, and monocot wrap miscellaneous will end up costing us about $425 from the materials we already have. And I will let avionics go then.
Different airfoils.
So I was mainly focused on the XFR5 aspect, right? I did an LLT analysis and also stability analysis as well as side slim analysis.
Okay.
And then Amir and I believe some of
That's a good answer. That's a good enough answer. Yeah. Another thing, and then I'll pass it over to Andrew. Why DIY landing gear? Why not just buy it off the shelves?
So We originally were going to do commercial off-the-shelf landing gear. We thought, yes, why would we make our own? We could just, find some. It is actually surprisingly hard to find landing gear with the ground clearance required because we have to have at least 8 inches of ground clearance for the banded wing system in our problem. The landing gear that you can buy for RC aircraft and those things for that size are meant to support aircraft that per scale don't have the same weight. The RC aircraft that the commercially purchasable landing gear minute are made mainly of foam and are hollow, like almost entirely hollow. So it's very difficult to find landing gear. We could find one example online, not just on Amazon, but on a variety of different places, RC hobby stores, and it was of dubious quantity. So it became almost cheaper, easier, and faster to just have it designed by our team and get it made.
Okay, very good reasoning, very good reasoning.
Question also pertaining to your landing gear, since you're doing it through your deal. Since you're making your own landing, you're not buying one off the shelf. And in previous competition years, the landing gear has sheared off both, I believe, the Flying Cougar and the Carbon Cougar. How much testing is going into the landing gear itself? What's being put into that?
So since we have not made our actual design yet for our landing gear, we just know that we're going to be making it. We haven't quite gotten to that point yet, but we will definitely be doing testing because again, we don't want to smack the ground because if our banner system touches the ground, it's mission fail. So we really do plan on doing
really heavy drop tests.
Yeah, that's also something we'll learn from prototype 1 is we come in for a landing.
I don't know if I didn't see this in the presentation or if I missed it. I didn't really see how there was integration, how you held like the ducks and the pucks together. I might have missed it through the presentation.
No friction fits.
Was that in there?
Speaking of which, I remember this being a thing for load. For the wing, there's that main spar and then there's the carbon rod. Just keeping in mind that carbon rod is probably only going to be good for keeping the spar or the ribs in place, but it's not going to be good at preventing the wing from twisting. And 4 feet is still sufficient to expand probably to where the wing might start twisting. So just be mindful that you might have to have a secondary like rectangular spar that goes across if needed.
That's the purpose of a 1/4 inch carbon fiber. It's an anti-torque bar.
Okay. There's a second bar behind the main bar.
You still get portion because they bend a bit.
As in, is that like just having a really thick main spar? Or is there a second?
No, there's the main spar.
Yeah.
I mentioned there is the main spar, and then behind that, about an inch from the trail, about 2 inches of trailing edge. Sorry, about half the trailing edge.
Okay.
Yeah, that black is a 1/4 inch carbon fiber ring.
Okay.
So that is specifically there to help counteract.
Is it hollow?
No, it's solid. It's solid carbon fiber.
So, yeah, that's what I meant. So having that one there, the way that it's placed in the wing, probably won't do too much to prevent torsion. It might. Test it out. Make sure it's good. Spar placement, you'll figure that out wherever the center of pressure is. But very often the balsa, or whatever wood, if it's the balsa wood or composite wood, those vertical strips that go along the full length of the wing are pretty good at creating a box structure. That's also good to keep twist away. So it doesn't need to be carbon to prevent twist. It just needs to have a good box structure to prevent twist. And keep in mind that the tips of those airfoils, when you do the monocot, make sure there's something keeping those in place because the monocot will really shrink and try to squeeze. That happens every single time I make wings. That the top and bottom of the ribs, wherever it's just a really long span, those will start bending because the vinyl is pulling on it. So just make sure that you have stuff to keep the structure of the wing from bending and bowing and twisting. Because it's going to start bowing, it's going to start twisting when you start to apply a heat gun to it. We've experienced that with previous planes.
I had a question about the lead time, like, have you guys looked into how much it would be and like the lead time for your landing gear? Like what company you'd be purchasing this from, so. Cause it's like, you're making it yourself and you're gonna get it manufactured, someone says actually, I'd assume a pretty good amount of time.
So we have not gone fully again, like I was saying earlier, it's not fully fleshed out yet. However, we do plan on using something either possibly through the university's actual machine shop, something of that sort, or just outsourcing.
Have you looked at the lead times at the university?
I have not, no.
They're very long.
Yes.
Yeah.
They're very long.
Capstone. Well, you might get priority as a capstone team. But even as a capstone team, you might be wanting like for capstone 2, we start building stuff. So we'll have something and it'll be a month. So it's like it's already March by the time the capstone team is even able to get stuff. So even for capstone, it's long.
So we plan, not plan, but we are in talks of planning of using aluminum, which is not entirely expensive, and also mentioned that, again, we haven't got fully into the details, so it may become slightly more expensive. But also it's not a huge, in terms of its complexity, our plan complexity, it's not crazy, and it's
Only the front being the.
we have quite a few different options.
Okay, because sometimes a lot of the front landing gear, there's portions of it where it's so simple that you can hand cut.
Oh,
Sometimes,
so I didn't,
preferably not. But
I didn't know that you were having a already provided back landing gear. I thought you were going to manufacture those.
No.
yeah, the back one's a little harder to manufacture for sure.
Okay.
You'll
Okay.
need to.
And the second question, and you can also jump in if you want to do this. I see a lot of y'all are seniors, about to be seniors, hopefully graduating. How in the spring semester do you plan to attract and engage freshmen and sophomores into the club in a way that kind of keep the ball rolling in terms of the quality of the team that, is happening right now? Because it took like 5 years from us to recover from COVID. And, like a lot of y'all know me since y'all were freshmen, and I probably was y'all's introduction to the team. And I'm glad to see that y'all have also, indoctrinated new freshmen into the team. Inducted, yeah, that's probably less culty. But yeah, what's the plan for attracting and engaging new people into the team, and also teaching them while you are doing a competition? Because I know it's not easy.
Prototype before winter break then.
I do want to mention as well specifically for, as I mentioned, structures on the co-lead, I'm a sophomore, so pretty young. I was honored to be part of the fuselage freshman under Andrew and Andrew under Tommy. It's a somewhat of a tradition that I'm trying to change around and kind of, so, anyways, my point with all this was, actually, I'm super proud. I wanted to bring up this slide. So that duct holder, that entire passenger section was actually made by one of our newest freshmen. And so part of, at least my personal as part of structures have two reasons. We are trying to involve not just members in one part of, like, not just the trade study part, not just the boring, or not boring trade study part, not just the fun CAD part, but involving them in everything. There's no, they truly get to feel involved, in my opinion, of course, not speaking for the rest of the team, but for structures at least, getting to be involved in everything, not just they get to see one part and somebody does another part, but they get to see everything. And I think that's important.
I will also say many of.
Yes.
I'm now gonna officially transition into the online questions. From Jalissa, she had a question, any risk tracking for the team designing the landing gear? Or for the team design landing gear?
Risk tracking?
Risk tracking.
Make sure they can hear you. You're right.
I don't believe we have gotten to that point. Once again, we have made up a decision that we will be making. our design and outsourcing it, but we've not gotten much further past that.
I have a question from